Hi, welcome back to Solve for X. My name is Lungelo Gonene, and if you're watching us on Facebook, please follow us. And if you're watching us on YouTube, please do subscribe to our YouTube channel. So today we are going to talk about the domain and the range. What is a domain and what is a range? Domain and range. So a domain, when we talk of a domain, we talk of all possible X values. Okay? We talk of all possible X values and we say X is an element of real numbers. Okay? X is not equal to an asymptote. Alright, so what do we mean when we say X is not equal to an asymptote, or why is X not equal to an asymptote? Okay, remember, an asymptote is a value. It's a value or values of X or Y where the function is undefined. A value or values of X or Y where the function is undefined. So let's talk a bit of about an asymptote. So let's say normally your first encounter of an asymptote maybe was when you are talking of a 10 graph. So a 10 graph is like this, right? And maybe, and okay, so you have seen something like this maybe. If you have not, this is a 10 graph. So these dotted lines here, they are what we call an asymptote. Okay, so what is the purpose of an asymptote? An asymptote is there to restrict the graph. So now that means this graph, this will not or should not touch this line. It will come closer and closer to it, but it will not touch it, because we say an asymptote is a value of X or Y where the function is undefined. So the function is undefined here. Normally when you do this, in order for you to get an asymptote in tan graph, what you do, you take whatever value, or when you punch your values in your calculator and then you get a syntax error, that error you will represent it by these dotted lines, and those dotted lines are your asymptotes. And also when you're dealing with this graph, when you're dealing with maybe a hyperbola, let's say this is your vertical asymptote and your horizontal asymptote. So you have your graph maybe there and the reflection there. Okay, so these are your asymptotes. They are there to restrict the graph. So that means this will come closer and closer to this line, but it will not touch it. It will come closer to this line, but it will not touch it. Remember, this line, the value of X here, this value of X, if you take this value of X, you substitute it where you see X, the whole thing will be undefined. Hence, then this is your asymptote. Okay, so then let's talk of the okay. So now when you have let's say you have a graph like this, a straight line, okay, y, x. So this one, when you have to, let's say the question says write down the domain of G. So you say domain, right? The domain of G, you will say x is an element of real numbers, right? And then where does x start and go? You say x is an element from, you see, this indicates continuity. So since domain, we talk of x values, this is the negative side of x, and that is the positive side of x. So that means, and this being continuity, and that it means that here the x starts from negative infinity to positive infinity. Okay? All right. Let me explain something really important. And so it's your choice of brackets. You see? So if it was a number here, you were going to put the square brackets. But since it's an infinity sign, it's going to be a bracket like that. So that's how you then do that. Okay? So let's say you have to write down the domain for a graph like a hyperbola, like this. Okay? So like this. Let's say maybe here it's -1. Let's say there it's 2. Okay? So x, y. So now the asymptote is -1. X equals to -1. There. This is the asymptote. So how is it? How are you going to write the domain for that one? You'll say x is an element of real numbers, and x cannot be equal to -1. So this is your domain for this graph. Okay, now let's move to range. Range, okay? Range. All possible y values. All possible y values, and then we say y is an element of real numbers. Y cannot be or should not be equal to an asymptote. Okay, so the same thing we did with the domain, it will be the same thing with the range, but the difference is y, because range is y. So now let's say they say write down the range of f of x. So let's say the f of x is this graph, the parabola. So let's say this is the turning point, and then the turning point, the value of y here at the turning point, let's say it's 1 and -2. The value of y is -2. So you say the range for this graph f, the range, you say y is an element of real numbers, and y should not be equals to sorry, not like this. Okay, sorry. and then y is an element from. Okay, where does it start now? Look, I want you to notice this. Remember, the value of y here is the same as the value of y that side. The value of y here is the same. Y is the same. So the difference is between the turning point and the continuity. So now you say y is an element. Where does it start from? Then you put your square bracket, -2 and infinity. Okay, so I want you to notice this, the square bracket here. But why do we start with the square bracket? Because this side, it's lesser numbers, that side it's greater numbers. We consider this as our number line. The right hand side of the number line are greater numbers, the left hand side are lesser numbers. So that's how we do it. So you cannot say positive infinity and -2, but -2 has to be this side and infinity that side. So now, what if the graph was given like this? What if the graph was this? Now, say it's 1 and 5. Okay, so remember, this is then the negative side of y. This is then the negative side of y. So that means we will have negative infinity. So then it changes to be y is an element from negative infinity, you see my bracket there, to the turning point, of which is 5. Okay, so that's where we end today. See you again next time when we look at another topic. Please do remember to subscribe and share this video with your friends. Thank you.